Hi there, I'm Kevin O'Connor, and welcome back to Ask This Old House. Today's show is all about energy efficiency. We've got some great tips for you. We're going to show you some things that any homeowner can do around the house for just a few bucks, and we are going to show you a brand new, state-of-the-art, carbon-neutral, renewable energy source. And here he is, Mr. Richard Trethewey.
How are you?
Wow, look at you working that bike.
I'm burning off a little bit of energy.
Well, you sure are. And what are you doing? You lighting a couple light bulbs up?
I'm my own utility right now.
Richard, you are brilliant. So what are you working on today other than this bike?
Well, actually, I'm heading out to show a homeowner an interesting software program. It does energy load calculations. Once you're armed with that kind of information, it is so easy to make smart decisions on saving energy and money.
All right, sounds terrific. And we're also going to get some good information from an expert who's going to join us up here in the barn. He's going to show us how to monitor the electrical use in your house. And there are a lot of gadgets and gizmos on the market these days, and we're going to take a look at some of them. But first, Tom Silva is going to show us one of the simplest things you can do around the house to save some energy. All right, Richard, now drop and give me 100 watts.
Here we go.
Faster, man, faster!
All right, let's see what you have here, Francis. I notice a gap right there.
I know, in the wintertime it's really cold. We get a gale blowing through there.
Wow. Well, I also noticed that there's a big gap right here in the corner of the door and under the door, and this weather stripping right here is failing.
I know, we put that on last year and it's coming off already. It just won't stick properly.
All right, well, what we're going to do today, we're going to fix this door. We're going to fix it with two different types of weather stripping. Across the bottom, we're going to use a mechanical weather stripping, and we'll replace all the weather stripping around the perimeter of the door. But to do that, we have to remove the door first. Draw it up high. And I'll just knock that out. All right, you want to do the other two?
Yeah.
All right, here's my hammer. Okay, now we're ready to do the top one. Now you notice that it started on the bottom and worked our way up. The reason is, oh, you all right?
Yes.
The reason is if you take the top one out first and work your way down, the door could fall on you. So we have more control by taking the top hinge out at the last one. There you go. All right. Now we can go outside and work on the door. All right, what I've done is I've made a stand to hold the door in a position so that I can work on the bottom of the door. You notice the door is on an angle?
Yeah, that's very clever.
Well, thank you. All right, now here's our weather stripping that's attached to the door, but not at the bottom. Remember that space? Okay, now here's weather stripping at the bottom of the door. And this is in a track, and this weather stripping slides into that track, closing that gap.
But the gap here means that's where the draft was coming through.
Right. Now we can simply replace this piece of weather stripping with a new piece of weather stripping. Slide it into the track, and the gap will be filled.
Yep.
But you remember that this door opens and closes all the time, and when it opens and closes, the weather stripping slides across the threshold.
So it'll wear out.
Exactly. So you'd have to replace it every now and then.
Yeah.
All right, so what I want to do is I want to use this piece of weather stripping right here, and it will actually go in the bottom of the door. And the way it works is this little activator right here, all right?
Oh, wow, that's really heavy duty.
Right. When you close the door comes in, here's the jam. The activator hits the jam, pushing the weather stripping down and filling the gap under the door.
Very clever.
All right?
Yeah.
To get started, I want to remove the old weather stripping and create a dado down the bottom of the door.
A dado?
Yep. Now the housing for the weather stripping is about 3/4 of an inch by 1 3/4 inches tall. I want to make a dado a little bit wider and a little bit taller than that. To do that, we're going to use a plunge router.
And what's this?
This is actually a jig that the router is mounted to, and this allows us to keep a straight cut on the bottom of the door. All right, let me show you how the jig fits the door. It fits snugly because I don't want the router to wander at all, okay? The router is positioned so that the cut will end up in the center of the door. I also want to take gradual passes, so I'm not going to go the full depth all at once. So to get started, I'm going to bring the router up, turn it on, and plunge it in just a little bit. I lock it down right here, and I let the router come down on its own. It's going right up. All right, now we're through. Now undo the router and let it come out of the hole. Pull the trigger with this finger. There you go. All right, now take it right out. Pull it right out. Take it right out of the door, yeah. Cut the router off. Okay, now what we have to do is we're going to cut the other side of the dado.
Okay.
Because the router bit is narrower than the dado that we need, we only could do a part of the dado. So we need to make a 3/4 inch slot with a 1/2 inch router bit. So to do that, I've positioned the router off center. So by flipping the router over without touching the template, the router bit Well, now when I push the router bit down, you can see the router bit, the edge of the router bit right there. It's
Yeah,
going to take
gonna cut some more of this.
it's
out.
going to take some more of this, centering the dado
Yeah.
as we do it. All right, and now we'll take it off, and we've created a dado.
Wow.
And you know what? It's the right size.
Great. We're clever, aren't we?
Here we are. All right, Francis, let's see how you did. See if it fits in the dado. The weather stripping fits right in there, nice and firm. That's great. Now we've kept it even with the top of the door right here. This is the edge that goes against the jamb because our hinges are right here.
Right.
All right, so my pencil will be a jamb. When the door closes, it hits the jamb, the weather stripping pops out.
That's brilliant.
Yep, and
Yeah.
it tightens up that seal or that space under the door.
Right.
It's great, Francis. I want you to use this tongue oil to seal the bottom of the door against any moisture getting in there.
Okay.
Plenty on there, that's right. Now with the door sealed, I'll insert the weather stripping, put it into position. Okay, now I'll screw it in place right here. Okay. All right, Francis, I'm going to try to work the door so that the top hinge goes together. Yeah. Okay, put it in there. Now take the hammer and tap it down. That's good. There we go. All right. Okay, now we have to adjust the bottom. You can see the gap. All right, so to do that, I open the door all the way so I can get to this little screw right here. I'm going to unscrew it, bringing this out further. So what happens, if this is out further, that means when the door closes, the travel has to go in further, pushing the weather stripping down. Let's see how that works. That's it. All right, now that metal screw or the trigger mechanism will actually hit this wood and damage it, and over time the weather stripping will stop working the way it should. So I'm going to put a mark right here, and there I'm going to install this metal plate over that mark, and then I'm just going to nail this in place. Okay, now our door is weathered tight across the bottom. Now it's time to deal with the two sides and across the top. Over time the weather stripping will wear out. All right, so what we're going to do is we're going to peel off this weather stripping right here. Peel this right off. Now this is not the original weather stripping. Someone has put this on. It actually has an adhesive back on it, and it sticks to the rabbit side of the jamb. Now we're going to get the piece off the top, which is different. It actually sits in a little slot or a curve. And this weather stripping has these little tabs right here that will sit in there, keeping it in that slot. This is a piece of the old weather stripping that we took out around the door, and these are the little fins that hold it into the curve. I want to replace it with this thicker piece of insulation right here. We still have the fins that will fit right into the curve, and this will really fill that gap. All right, now I'm going to slide it right into that curve, and I want to push it tight against the left side and work my way across. Now I cut the weather stripping a little longer so it will fit tight from left to right. Now we're ready to install the weather stripping up the side of the door jamb. But before we install it, I want to remove this tab right here in the back so that the weather stripping will overlap the one above. So to do that, I'm going to cut this piece right here on an angle. All right, let's see how that looks. Okay, that looks pretty good. All right, now we have to push it into the curve. All right, Francis, you ready to give the door a try?
Yes, I am.
May have to push a little harder. We have a lot more weather stripping there.
Okay. Look at that. Look, no gaps. It's going to be much more comfortable in the winter. Thank you so much.
Well, it was my pleasure, and you'll save some money on your energy bill.
We will.
Paul, you're an energy efficiency expert. We've worked with you in the past, and we've asked you back because we need you to help us think about how we monitor the electrical use in the house. How do we do that?
Well, you can start by looking outside your house at the electrical meter.
Okay.
And what I've got here is a 60-watt incandescent bulb hooked up to that meter. And the trick is to watch the spinning dial.
If that is spinning, we are drawing electricity, and it's actually spinning relatively fast.
Right now I've got a 15-watt compact fluorescent bulb on the other side.
Look at that slow down. And so I guess that's the trick. We want to get that wheel to spin as slowly as possible with the same output.
Exactly. So in this case, technology has come to our rescue, and we can use about a quarter of the power to give it the same amount of light.
All right, so how do we actually monitor the usage of individual appliances throughout the house?
Well, moving inside the house, we can use any one of these electrical meters, and these are individual appliance meters. They each are, they work about the same. They have slightly different features, but essentially you plug your appliance into the meter, and you plug the meter into the wall, and they will tell you how much power or dollars that appliance is using.
Plug my refrigerator into this device, and it'll tell me how much power and what that refrigerator is costing me to run?
Exactly.
Okay, so that's really good information. I guess the downside is you either have to have one of these for every appliance you want to measure in the house, or when you're done measuring the refrigerator, you unplug this and you plug it into your, say, washing machine.
Right. So the next thing that you might want to think about is a whole house electrical meter. And there's a couple of different devices out on the market now as well. So this, for example, will clip onto your power meter outside, and there's a little optical reader that will sense how fast that dial is spinning.
So it actually watches that dial spin, and then what, it sends the information to this monitor here?
Exactly. And this monitor goes inside the house. You can carry it around with you, turn things on and off, see what it changes on your power or dollar consumption
Gotcha.
scales.
This is a wireless version right here. Does this work the same way?
Pretty much the same way, except that this clips onto the wires inside your panel.
Gotcha. So in this case, it's also good information about the whole house, but this unit won't tell you exactly what just the refrigerator is drawing and whether or not the refrigerator is a power hog.
Right, exactly. Now combine these technologies, and we have the next level of whole house energy management and monitoring systems.
What are we looking at here?
This is a breaker box, and we've got current sensors that clip onto each wire.
Gotcha.
So we monitor each circuit individually.
So here's the circuit for the washing machine, and as this washing machine draws load, the sensor reads that and sends the information where?
Over to this power management box. It gathers all of the data from the circuits and sends it to the internet, where you can look at all of that data on your computer.
Let's have a look at that.
All right, we've actually got a live hookup to a real house here that's using 3,122 watts. You can look at that odometer on the left side there.
Well, and there it just changed
And-
pretty quickly. So that is actually a real-time reading of what's going on in the house.
That's right. So somebody just came home and turned something on, probably.
And then over here to the right,
That is a list of all the circuits and appliances that are on.
clothes dryer is on, the mudroom and sink, oil boiler, all the way down to, ends with the home office.
Okay, Kevin, scroll down to the bottom of the page, and you'll see that pie chart.
Oh, yeah.
And we can zero in on any one of those end uses.
So this is the usage over the last 30 days, and there it is. The refrigerator used about 8%, the kids' bedroom and some circuits in the basement 19%, and the home office, that looks like the biggest at almost 28.2%.
That's right, the biggest user here, but I have to tell you, I have this equipment installed in my house, and my power usage jumped one day. I could see that very clearly. And I scrolled through all the pieces of this graph, and I discovered that my refrigerator was using twice the power that it normally does. And I troubleshot that back to a bad defrost coil. Replaced that for $20, my power use is back where it needs to be.
So I can click on an individual slice of this pie. I'm going to click on the home office here, and it'll give me detailed information of just the home office.
Exactly.
Oh, look at this. I'm looking at the chart. And here it is at about 5:50 p.m. There's a spike, so the homeowners come home and they turn on their computer screen, their printer and such, and that explains this spike here.
That's right. Now take a look at early in the morning. We've got a 5:51 time marker there, but before that, we can be pretty sure nobody's in the office. They're probably still asleep.
It's 4 o'clock in the morning, no one's in the office, yet there's still what looks like about a minimum of 150 watts being used in that office
Looks
at all
like
times.
phantom power to me.
So phantom power is this idea that even though you've turned things off, they're still drawing a load.
Exactly.
You turn your computer off, but the printer is still on, or the modem is still on, and that's still using electricity.
Right, and in this case, it's 150 watts. It's like leaving a 150-watt light bulb on all the time.
So this helps us monitor it. How do we actually manage that? What do we do about phantom load?
Well, we've got some more technology, fairly simple to use. Let's take a look at it.
Okay. Power strips, huh?
Right, pretty simple to use. Plug all your peripherals in here. When you're done using your equipment, you turn it off.
Gotcha.
Everything goes off.
So the only problem is that you've got to crawl behind the desk and turn this off.
That's right. So let's get a little more sophisticated. We've got a timed power strip now. Again, you plug everything into the strip, and you program your timer to turn the home office off at midnight, for example. Everything goes off while you're asleep. You don't even have to think about it.
All right. But there's always something that I don't want to stop drawing that phantom load because I don't want to have to reboot it or reset it every day.
That's right. So you might want to consider a controlled power strip. And these use a controlled outlet to turn these outlets off. So, for example, your computer's plugged in here, and your monitor and printer are plugged in here. When your computer goes off, these outlets are switched off through an internal control.
So no phantom load can come out of those outlets. And then the red ones here?
Those are always hot. So your fax machine, for example, might get plugged into there.
Well, that's great. So pretty intelligent. All right, so lots of good information on how to monitor and, most importantly, how to manage our electrical load. Paul, thank you very much.
Thank you.
This is great.
How we doing, Barry?
Great. We're all just about all set, Rich.
Great, good job. Now, this is a gas-fired cast iron heating boiler. It was installed in this house in about 1975. Now, any boiler is measured in BTUs. That's British thermal units, and it's a unit of energy. Now, this boiler was sized at 175,000 BTUs. Now, the owner felt it was time to upgrade to a more modern heating boiler, and he's got it installed right here in this closet. We'll check back on that later. But the size of this new boiler should surprise you. So, Barry, it was time to change the heating boiler. Tell me the whole story.
Well, I wanted to become greener like everyone else, and I wanted to save money with the rising energy costs like everyone else.
Good for you.
So I caught up some plumbers, had them over. The prices were all over the place, as you can imagine.
Yeah, I've heard that.
And more importantly, the size on the heating systems were all over the place.
So what are some of the sizes you heard?
All the way up to 175,000 BTUs.
I'll predict that guy went down and just looked at the boiler downstairs and just matched it.
I guess so. Who knows?
What other size do you hear?
Then another guy came and measured the linear footage of the baseboard heating and times it by a factor of 600.
Okay, I've heard of that one before.
And then another one measured the square footage of the house.
Okay. Well, you know, all those seat of the pants, rule of thumb, back of the envelope methods will give you some size heating boiler, but it'll generally be oversized. And oversized equipment is really inefficient. The only thing a heating boiler needs to do is to keep up with the heat loss of the building. Now, the heat loss is determined by how warm do you want it inside versus how cold it is outside. And the big variable is what type of windows do you have, how much insulation do you have in the walls, floors, and ceilings. Now, to get that number, we have to do a heat loss calculation. Today I brought a computer along. I'm going to see just what this house's heat loss is.
That would be great.
Now, the nice thing about a software program like this is you can really enter a lot of data. And it starts by telling the system where we are. So it has weather data right here for all over the planet. We tell it that we're in Boston. When we tell it in Boston, it will know at that point all the different temperatures that occur at every single month of the year. And that's important to heat loss. So now, once we've got that entered, we now want to start entering your building. There's a graphical interface. You can see the graph paper right here. And before we enter the rooms and all the other data, we tell the system what type of insulation you have in the walls, what type of windows you have, what type of doors, and then we site them in the building. So we drag this room, and here's the family room we were just in. We're in the kitchen right now. You got about 2,000 square feet of living space. Next, I lay in the windows where they are, the doors. Now, the system also takes into account siting, which is north, which is south here, so you know solar gain, and also the overhangs on the roof. It even knows how many people live in the building and also what appliances you have. So once we've done that, we hit this button right here, and it tells us that this building, your house, has a heat loss on the coldest day of the year of 90,485 BTUs per hour.
Wow, so that's what I need?
That's right. So 90,000. Now think about it. If you had that guy put in 175,000, that system would have been 2 times too big, even on the coldest day of the year.
So that would be like throwing money out the window.
Absolutely. Very inefficient. It's in having this heat loss number that you have the real confidence to size the boiler correctly. Let's see how they're doing downstairs. Now, the old boiler sat on the floor. The new boiler is a wall-hung gas-fired condensing boiler. It vents to the outside through this pipe, and it gets its combustion air through this pipe. The old boiler used to go to the chimney over there. Now, this boiler is sized at 110,000 BTUs.
Well, I'm a little confused because I thought you said I needed 90,000 BTUs.
Well, I did. But there's 2 numbers on any boiler. One is the input, how much gas that boiler consumes, and you pay for it. The other is the output, and that's always a little bit lower. And even though this is really efficient, it's right in the 90s for its output, and that's perfect size for you.
Well, I'm really excited about that, and I'm really excited about all the incentives I got.
So what do you get?
Well, I got an interest-free loan from the state. I got $1,000 back from my utility company, and I'm getting a $1,500 tax credit.
You did all right. You made all the right moves.
Thank you very much. I really appreciate it.
And on top of it all, you're going to save a ton of fuel.
All right, so you got him into a smaller boiler. But really, what's the crime of using twice as much fuel if you're using it for half the time?
There's really no upside to oversizing. It's really the biggest challenge we have in the heating and cooling industry. If that boiler or furnace is too big, it's inefficient. It's on and it's off, on and it's off. And overcycling just kills it. It's even worse in cooling season. If that air conditioner comes on so fast, it doesn't have a chance to take out the humidity in the air, and it's on and off, it's inefficient. You also end up with clammy air because it's filled with humidity, and the efficiency of the equipment doesn't last. It fails pretty quick.
Okay, so if you're buying new heating or cooling equipment, this is some good software to have.
Absolutely. It's actually good on a couple different fronts. One is it can analyze the equipment, but we can also look at the shell of the building. And the shell is the walls, floors, ceilings, and windows.
Right.
Now, in this example, I put a different house in, and I loaded in the type of windows that were there. This house had the typical 50s windows, single pane glass, no storm windows.
Gotcha.
And the heat loss is 74, just about 75,000 BTUs.
Yeah.
And with this software, I can come up here and I can change the type of windows. And let me just click that on. And I switch to double pane windows. Look what happens. Heat loss goes down below 60,000 BTUs, about 58. So that's about a 20% savings by changing the windows.
Wow.
So with software like this, you can look at the two variables, the efficiency and the shell, and sort of compare where your money is best spent.
Okay, and can I get my hands on the software?
Well, this is actually used generally by HVAC contractors or energy auditors.
All right, so some great ways to think about saving energy in your homes. Thank you, Richard. Actually, an entire show about saving energy in your home. We hope you enjoyed it. So until next time, I'm Kevin O'Connor.
I'm Rich Trethewey.
For Ask This Old House.
So let me load your house in here. Come on.
Oh, no, that kind of makes me nervous. Does it help that it used to be pink?
Or a tip you'd like to share, please let us know. Visit our website, pbs.org, for expert advice, step-by-step videos, and much more. Next time on Ask This Old House, we provide the place to pitch the perfect picnic.
Now, we could spend a lot of money on some expensive materials like cedar or teak, but that's not what we're up to.
That's next time.